Hey y'all, it's Mrs. Hoke, and today we're going to talk about solving 2x2 systems of equations. So when I say 2x2, that means that we're going to have two equations that have two variables that we're going to solve for. So each of those has the same two variables. So we're going to talk about three different ways that we can use to solve those. The first one being graphing. So if we look at this first example on your notes page, you see that we have two equations, y equals negative 3x plus 2 and y equals 2x plus 2. So those are both already in slope-intercept form, y equals mx plus b. So you probably remember that from Algebra 1. Your slope is the m, and your y-intercept or starting point is the b. So both of these have already been graphed for you. We have y equals negative 3x plus 2 as the yellow dotted line right here with the negative slope. And then you have y equals positive 2x plus 2 right here. So after we graph those, where do you think our solution is? Yeah, good. Our solution is going to be where our two lines intersect. Okay, so right here, our two lines intersect, and that's going to be the point 0, 2. Remember, we go side to side first, so we did not move side to side from our starting point right here, the origin. Okay, but we did go 2 up. So if you remember, all coordinates are in the form x, comma, y. So that means that for these two equations, our x equals 0 and our y equals 2. If I plugged those values into either of those equations, we would get a true statement. Okay, you can also write your answer as the ordered pair 0, 2. That's fine as well. Okay, let me show you how I would plug this in. So if I wanted to plug that in to check my answer, I would plug a 2 in for the y, bring down everything else, plug a 0 in for the x, and then solve this out. So negative 3 times 0 is 0. Copy down everything else. Okay, 0 plus 2 is 2. Since 2 equals 2 is a true statement, that means that 0 and 2 satisfy the equation y equals negative 3x plus 2. Okay, we would do the same thing for our other equation. So if I plug in a 0 for x and a 2 for y, we find out that 2 equals 2 is a true statement. So this is indeed the correct answer. Okay, moving on to another method. So once again, we have two equations with two variables, except this time it says we're going to use substitution to solve. Okay, this is also still a review for Algebra 1, but probably not something you're as familiar with. So for substitution, we want to choose a variable to get by itself in one of our equations. So we want to have one of the equations in either x equals or y equals form. It doesn't matter. So for this example, the bottom equation is actually already in isolated form, meaning we have the y all alone. So what we're going to do is we're going to replace our y in this top equation with this whole piece, because y equals 3 plus x. So anywhere I see a y, I can replace it with 3 plus x. So I'm going to come out here to the right, and I'm going to say 3x plus 2 times y equals 1. Remember, y, I can substitute in with 3 plus x, because anywhere I see a y, I can replace with 3 plus x. Now, we've got to do a couple of steps in order to simplify this down and solve. The first step I need to do is distribute out this 2. So that's going to be 2 times 3, which is 6, 2 times x, which is 2x. Then I'm going to bring down my 3x and bring down my equals 1. Okay, once we do that, we can combine together like terms. 3x plus 2x is 5x, I still have a plus 6 equals 1. And then I need to solve for x. So I'm going to subtract 6 from both sides. 5x equals negative 5. Therefore, x equals negative 1. That last step I would have gotten by dividing by 5 on both sides. Okay, once we have that value, I can take that value and replace x because x is negative 1. So now we have y equals 3 plus negative 1. So 3 plus negative 1 is 2. So for this particular problem, my ordered pair solution would be negative 1 comma 2. And once again, you could take that and plug it in if you wanted to. Okay, so that's substitution, where we get one of our variables by itself, plug that into the other equation, and start solving from there. Okay, our final method we're going to talk about is elimination. So elimination, we're going to want our equations in standard form, meaning that we have the variables on the left and our constants on the right. So constants are numbers that are not attached to letters. Okay, you want to make sure that the letters on the left side are in alphabetical order. So these two equations are already in standard form. So we have 5x plus 3y equals negative 19, negative 8x minus 3y equals 25. So here we want to try to eliminate one of our variables by adding our equations together. So if I add these two equations together, 5 plus negative 8x is going to give me negative 3x because 5 plus negative 8 is negative 3. Okay, in the center, negative 3 plus positive 3, so the negative 3 on the bottom, the positive 3 on the top, cancels out. Okay, that makes 0 because positive and a negative of the same number cancel each other out. And then over here on the right, I have negative 19 plus 25. That's going to yield a positive 6. So now I have this equation, negative 3x equals 6. And from here, you'll be able to just divide by negative 3 and find out that we have an x value of negative 2. Okay, once you get that, you can pick either equation to plug it back into. We're going to have to solve for y. So I'm going to just choose to plug it into the top equation right here. It doesn't matter. So I have 5 times negative 2 plus 3y equals negative 19. 5 times negative 2 is negative 10 plus 3y equals negative 19. I'm going to go ahead and add 10 because we're trying to get that y by itself. We're trying to isolate it. So, whoops, I don't know why I put a negative. 3y equals negative 9, and we would divide by 3 on both sides. So y equals negative 3. So for this problem, I could write my ordered pair solution, my xy coordinate, as negative 2, comma, negative 3. Now, once again, if you wanted to plug those in, you could go back and plug them into your original equation. There are going to be times where you don't have two values that automatically cancel out like these did. So you might have a positive 3y and a negative 6y, and you'll need to do a little bit of multiplying to get them to match. So if you come across problems where you need to do that, I will include some additional examples for you to watch on that.